A good example to use with exponential decay or depreciation is purchasing a car, because cars lose value as soon as you buy them, right? So a car that was purchased for $24,000 is represented by the 24 in that function. Um, the B value there is 8/10. So first question is, does the function represent growth or decay? This is decay because that value is less than 1. Cars, in almost every case, are not going to gain value as you use them, as after you buy them. They're going to lose value, right? So the fact that the B value is less than 1 represents exponential decay. So what is the rate of decay for this function, and what does it mean? So if the B value is 0.8, that means the rate of decay is 0.2, or 20%. The other way to think about it is, well, the car's value is going to decrease by 20% each year. The B value represents directly the value that the car is going to hold each year. So if it's losing 20% each year, the B value of 0.8 means it's holding 80% of its value each year. So let's graph the function. All right, so here's the function graphed. Find the value of x when y equals 5. So it's about there, right? The value of x when y is about 5 is about 7. So that means after about 7 years, the car is going to be worth about $5,000. The y-intercept is going to represent the value of the car when it was first purchased. So that's at about 24,000 there. And the asymptote is going to be y equals 0, right? Because the car will never cross into negative value. So let's take a look at the you try it questions. So I want you to try the same type of question. Consider, though, before you start, the B value is greater than 1. Okay, so consider what that's going to be doing to the population of the hawks in the region. All right, so pause the video, give it a try, and then come back. All right, I chose to graph this on Desmos. So let's take a look at that. Also, well, we can answer question A without even doing that, right? Since the B value is more than 1, population will be increasing. So let's graph the function and then figure out in what year the number of hawks will reach 280. So if we look at the graph, right, we have the function graphed. I had to zoom out a bit to make sure it all fit. You got your y-intercept at 220, right? If I want to figure out, well, where is it about 280? Let's just move the cursor up right about there. So at exactly 5 years, it's about 280. So the answer is about 5 years. What we're going to be able to do when we move further in this content is be able to take that function, substitute 280 in for f of x, and solve for x. So we could do it algebraically instead of graphically. We'll eventually get there. We're not there yet. We got to do a couple things to be able to get there, but that's where this content is headed, being able to solve for that x algebraically as opposed to just looking at it on a graph and saying, all right, well, 280 is at about 5 years or whatever. So again, your answer here is 5 years. And let's take a look at example 5.